In this video, we're going to look at the energetics of forming a solution when your solute is an ionic solid. And it's much like the previous video, except we have some more terms we need to learn about. So when you mix an ionic solid into water, the energy that you get out is called delta H hydration. So when you're mixing your ion plus water, that energy is actually called delta H hydration. Now you're hydrating your ions. And so let's just think about the various forces that are involved when we combine an ionic solid in a solution. First off, the ionic solid is held by ionic bonds. All of these bonds together form your lattice energy. It is the energy that is holding together your ionic compound. Now, in the last video, we said we have to separate the solutes, and we call that energy delta H solute. It is endothermic, so we have to put energy in. Well, the energy we put in is using to break apart the ions, and the energy holding the ions together is the lattice energy. Therefore, delta H solute is equal to the delta H lattice energy, but different signs. So think about it this way. If we have ions that are separated and we put them together, we get some negative energy out. For example, let's say putting sodium and chloride together is negative 20 kilojoules per mole. Well, to break apart those sodium and chloride ions, we have to put that same exact energy in. So to break apart sodium and chloride, we have to put in 20 kilojoules of energy. So the first thing we need to do is break apart our ions, which is delta H solute, which is equal to our lattice energy. Now, water, we have to break apart those interactions as well, and those attractive forces are hydrogen bonds, so we put energy into that as well. Now, when ions and water interact, they have favorable ion-dipole interactions. And the heat of hydration is the heat released when you put 1 mole of ions into water. So here on this plot, we have breaking apart our salt. We have breaking apart our water as well. We combine those with water, and that will always be a favorable interaction because you are forming new ion dipole interactions, and the energy from your ion dipole interactions we call delta H hydration. And like the previous video, mixing ions and water can be an overall endothermic or exothermic process, and that's called delta H solution. And so delta H solution is equal to delta H hydration plus delta H solute, just like in the last video. But since we're working with an ionic compound, we can also say that's negative delta H lattice energy. All right? So let's just take a look at the interactions that are formed. And we form these ion dipole interactions. Very favorable. You get a lot of energy out by making these, which is good. And that's because your ions, which are charged, are surrounded by your water molecules, which are polar, to have all these favorable interactions. So your negative oxygens surround your cations, and your positive hydrogens surround your anions. Energetically very favorable, very exothermic. And we say when this happens, the ions are becoming hydrated, surrounded by water. That's why it's delta H hydration. Right? So this is just a review, a refresher of the energetics of solution making. So the enthalpy of solution is the enthalpy of your solute plus solvent plus mix. If this is still confusing to you, I would highly recommend rewatch the previous video so you can know what these terms mean. Well, in terms of ions, delta H solute is delta H lattice energy, and we can say delta H solvent and delta H mix is delta H hydration. So for ions, delta H solution is delta negative delta H lattice energy plus delta H hydration. It might be confusing seeing all these delta H's. It just means heat energy. So do we get out heat energy or do we have to put in heat energy? Right? Now, we can actually learn something about delta H hydration through delta H solution. Because we always know lattice energy is always negative. Lattice energy is always going to be negative. And so we can see how big is forming these ion dipole moments based on the sign of delta H solution. So if you have a delta H solution that is very large and very negative, that means the lattice energy wasn't all that strong. It's very easy to break apart these ion molecules. And the new ion dipole interactions you are making are very favorable. These ions really want to be hydrated. And so the solution heats up. Well, on the reverse, if your delta H solution is positive, that means it was very hard to break apart the ions to begin with, and the ion dipole interactions you make aren't that strong, so the solution is cold and it has to take in energy from the surroundings to mix at all. And that's it for the energetics of mixing, and I'll see you in the next video.